Hello, YouTube RJ. Hey, today we're going to take a look at my Hexbeam. Now, when I decided to buy a Hexbeam 4 years ago, I had a lot of questions. And so I went on YouTube and I searched the web and I found a lot of people talking about their Hexbeams, but they didn't really give me the answers I wanted to know, whether I should buy one or not. They talked about how it went together. They talked about how great it was. They talked about how there worked all these stations. They never talked about the ruggedness of the construction, how it stood up to storms. I saw a few things about ice storms, but really that's about all I saw. So after thinking about it, I decided to do a quick video talking about hex beams. Should you buy one or shouldn't you buy one? And there's a lot of factors involved in this. Before the video's over, we're going to talk about them all. But first, let's just take a quick look at my hex beam and see how it's held up after 4 years, 2 hurricanes with over 100-mile-per-hour winds. Let's get up there and take a look. Okay, let's jump back into the lab and talk about hex beam antennas. Okay, let's start out by talking about which hex beam I have. And let's jump over here. I've got the NA4RR hexagonal beam antenna. Now, first I want to start by saying I'm not affiliated with this company. I'm not even saying this is the best hex beam out there. I got this because a buddy of mine had bought one and really liked it, and it's local here in the state of Florida, so shipping was a little less, and they also had them in stock at the time. Don't take this as any kind of endorsement or, hey, this is really the best one, RJ says so. No, that's not what I'm saying. What I'm saying, this is what I have, what you were looking at. This is leading up to, this is what I have, here's the options I did, here's why I did them. Then we'll go into who I think should consider a hex beam and why. And then we'll talk about who should not consider a hex beam and why. And then we'll jump over to take a look at the Nano VNA scan of my hex beam currently, kind of show you what to expect out of them. And then I'll talk about my experience with the hex beam, what I saw after getting the hex beam as far as performance and such, and that'll kind of finish it up. And so I think this is going to help you make a decision whether you want to buy a hex beam or not. Let's get into talking about my hex beam. Okay, my hex beam, as I said, is the NA4RR. Here, and he's like out of Pensacola, Florida. One of the things that surprised me is I downloaded and printed this currently to have the current information, and I was really shocked at the price. I don't think this has went up much in the 4 years I've had mine. That's surprising. As we all know, everything went up dramatically in the last 4 years, but the whole beam antenna without any additional accessories covers the 6 bands, 6 meter, 10 meter, 12 meter, 15 meter, 17 meter, and 20 meter is $700. It has some really good reviews on Hamnet, but bear in mind, so do all the other KIOs and all the other hex beams. There's a lot of hex beams out there, and they basically follow the exact same design. What you want to think about this is you've got the kit, and then he says here, if you do not already have a balun, don't forget to get one. Point taken. You need a 1-to-1 current balun. If you can see the picture down here, they sell a right angle adapter for the fitting up there that lets you bring the cable straight down so you don't end up with this mess. I recommend if you don't have a 90-degree fitting, get one. I recommend you go ahead and get a balun. Now, if you're going to put the ends on your cable, you can buy the regular balun, and it literally slips over the cable before you put the end on your cable. If you're buying your cable with ends on it already, they've got these split bead ones. So that's the 2 different ways you can do the balun on this particular kit. Now, other hex beams probably have different options, but probably pretty close. There's another option down here for $38 for ice cords. Ice cords are for people up north that get ice. Ice is heavy, and it can really pull on those fiberglass poles. And we're going to get into that in a little bit about the problems with ice and at what point do you need to consider that. I recommend going ahead and paying the extra 38 bucks to put the ice cords on, even if you're not in a heavy icing area. And the reason for that is the cords, if you notice, ran across from the top of the post over the tip of the fiberglass rods. They run from the top of the post over, and your fiberglass pole arcs up and it hooks to the end. These come off the top as additional cord and runs down to the middle of the fiberglass pole. Just gives it more rigidity. Being that I see a lot of high winds, I did add that onto mine. $38 when you're putting up a $700 antenna is very little. If you don't live in a place that gets ice, decent ice, you might not need this. I did do that. Then you get into individual parts. That's another nice part about his. Watch when you buy Hexbeam. Some of them don't sell you independent parts. So if something breaks, maybe they will, maybe they won't. Here, he's got a list with the prices. You already know. You can buy a new base plate, which is like the main part of the antenna. You can buy the center post. You can buy everything. You can buy every individual item to build this thing, each individual element. So that's kind of a nice thing. Now that we kind of just run over what mine is, let's talk about some things. One is ice. Actually, let's just talk about durability. I've had my Hexbeam 4 years. I've done nothing to it. Actually, let me take that back. I did. About a year after I put it up, it was rotating not with the rotator. That's right. I forgot about that. And so I cranked it down. We laid it down just low enough I could get to the bottom of the antenna. And the bolt that goes through there, the nut had backed off and the bolt had come out, but it had just regular nuts on it. So that's a suggestion I'll give you. If your pin bolt through the bottom of the hub that goes on your rotator, if it doesn't have elastic lock nut on it, go get elastic lock nuts. Don't use split washers and a nut. Save yourself some aggravation. That's the only time I've ever had to work on my Hexbeam. I got up there thinking, man, what's broke? Got up there, my antenna, you could just spin it around without the rotor moving. And then I realized there's no bolt in it anymore. The pin bolt's missing. For 3 years, I've never had another problem. So that's number one. Are they durable? What I said is true. Yes, mine has seen 2 major hurricanes come through Florida, come right over us. We've seen winds in excess of 100 miles per hour. I'm pretty sure we've peaked as much as 115, maybe a little more than that at times. Sustained winds well over 100, peaks maybe of 115, 120. Pretty scary stuff, as you can imagine. I've never taken my antenna down for a hurricane. I have cranked that aluminum crank mast down, brought the antenna down about 10 feet. And the reason for that's you're not going to get the antenna out of the wind, but what it did was because it's 2 sections of aluminum tower, by shortening it, I'm doubling up that tower, making the tower stiffer. I didn't want the smaller section sticking way out in that wind. I wanted to bring it down. I was worried it could bend or break the tower, so I brought it down. Still in the wind. There was times when the winds were 60, 70 miles per hour where I could just step out of my back door when the winds were coming from a direction that wasn't going to impact me directly. And at 70, 80 miles per hour, you look up there, that thing is flopping around like a willow tree. You just know it. When the first hurricane came through with those winds, I knew when I went out, it was at night. And I knew when I went out in the morning, I'd look up there and that thing was going to be gone or a tangled mess. And I was completely surprised to find that it was intact. Now, in the video, you might have noticed some of the fiberglass poles are leaning one way or the other. Well, take into consideration it's been through 2 hurricanes, and understand that's not a big deal. The cables run through little hoops. They're not the metal cables that make up the transmission and reception wire, the elements. They're not connected to those poles tight. They slide. In heavy winds and stuff, those poles can slide and lean over this way and lean over that way. It doesn't really affect anything. As you'll see when we go to my Nano VNA, you'll see that it's perfectly in tune and works great. But what happens is when I get a good wind and it gets off like that, there's enough friction on the cable, it'll keep the fiberglass leaned over until I get wind jostling around hard, maybe from a different direction, and it'll bounce. And sometimes it'll go a little the other way. Sometimes it'll straighten up. So you never know what you're going to see up there after a wind. Sometimes they're leaning over a little like that. Also understand some of that lean that you were seeing today is it was very windy. If you couldn't tell from the drone and looking at the trees, the winds was getting it today. We probably had 30 mile per hour winds. And so some of it was the wind was blowing a certain direction. So if you saw the 2 that were leaning the same way, that's because the wind had been pushing them that way. They'll blow around up there, and I think that's one of the reasons they hold up as well as they do. I think they're like a willow tree. I think because they can flex and bend and give, I think that helps them stand up. Okay. Now, am I promising your Hexbeam is going to survive 115 mile per hour winds? No, I can't promise you that. I can only tell you that mine did surprisingly well. Ice is the downfall of a Hexbeam. There's nothing that does a Hexbeam in more than really heavy ice. The fiberglass poles cannot handle the weight of massive coatings of ice. If you live in a climate where you get heavy ice, I don't think a Hexbeam is a good solution for you. from a holding up, how they stand up and stuff, just talking about that. If you get a little icing from time to time, that's not what I'm talking about. If you're in one of those areas that get ice storms every year that pulls power lines off poles and takes the trees straight down, Hexbeam's probably not going to survive that. So take that into mind. That might be a reason for you not to get a Hexbeam. Let's get on to other reasons you might want a Hexbeam. Let's get into who should buy a Hexbeam. Okay, I've got some notes here I'm reading from to help me keep on track, so bear with me a little bit. Didn't want to miss important points, and if I just freestyled, I don't normally script my stuff. If I just freestyle, I was afraid I'd miss some important points that I had. So who should buy a Hexbeam? If you need to work with a light tower, or for whether it's economical reasons, or you have it, or base, or whatever, if you need to work with a light tower or a light rotor, and you're limited with turning radius, a Hexbeam might be a good choice for you. They don't have a big turning radius like the multi-element, 4-element quad Yagis and such. They're going to be tougher than the 4-element Yagis. I can promise you a 4-element Yagi is not going to survive 115, 120 mile per hour gusts. I haven't seen one that I think anyone would believe that's going to happen. Okay, just keep that in mind. If you do not have a beam, so all of these add up. If you do not have a beam and you want to get more countries and more DX, you're a good candidate for a Hexbeam. If you want one antenna, pay once, put it up once, have it in one spot, have one rotor, one tower, and have a bunch of bands, you're probably a good candidate for a Hexbeam. 6 bands, it's nice to have on a single antenna. There are some Hexbeams that have 40 dipole rods or whatever. I hear a lot of mixed comments on them. Seems to lean mainly to does not work that well. Do your own research. I don't have any experience, but I can tell you my research pointed at 40 meters, add-on little kits for Hexbeams. It just doesn't fit into the design very well. If you do not need the ultimate front to rear ratio, and you don't need the ultimate pull that last dB or 2 out of the signal, you may be a good candidate for a Hexbeam. And what I mean is, if you're going to buy a directional antenna and you need the absolute most front gain and the best front to rear ratio, Hexbeam is probably not your thing. You're going to need to go to a multi-element Yagi or something. Much bigger rotors, all that, more wind load. If you want a cost-effective multi-band directional antenna, you can't beat a Hexbeam. You really can't. When I say you can't beat it, I don't mean you can't put a better antenna up that will get a better signal. What I'm saying is overall cost, everything about it, cost, space, weight, wind load, what kind of tower you have to have, the expense there, what kind of rotor you have to have, expense there. You can't beat a Hexbeam. I have heard of many people using Hexbeams on old TV rotors and working perfectly fine. The wind load on them is not very high. I think that pretty well sums it up for the people who should consider buying a Hexbeam. Who should not buy a Hexbeam? People with serious ice storms, already said that. If you have other multi-element beams, probably a Hexbeam isn't a choice for you. Because if you're running a 4-element Yagi, it's going to have a lot more gain, a lot more front to back ratio than a Hexbeam. So why would you buy a Hexbeam? Want the ultimate in front to rear ratio. If you got to have the very best FR ratio and you need every dB you can get on that weak signal, Hexbeam's not the beam for you. You need to go to a bigger, more expensive setup. They're very good. Don't get me wrong. Big difference in that and like a dipole or inverted V or a bazooka or any of those. If you have room for much larger turning radiuses and you really want a bigger antenna, Hexbeam's not your thing. You're lucky. If you got a big stout tower, big stout rotor, lots of turning radius, money's not an issue. Maybe some bigger antennas are probably in your future. Now the question is, do they work? Well, I'm going to start that out by jumping over onto Nano VNA and take a look at the literal performance of the antenna, SWR and the bands, and let you see. We're going to look at everything from 20 meters to 6 meters, which is what this antenna is intended for. I'm going to show you what the performance looks like as far as SWR and how it falls out on the bands. Okay, here we are on Nano VNA Saver. Let me go ahead and do a fresh sweep. I'm sweeping from 12 megahertz to 54 megahertz because I want to pick up 20 through 6, which this antenna covers. And let's finish it up, and it's done. and you can just barely make out the white streaks of the different bands. And we're down here at the 6 meter, and you can see that we're at the very edge of the 6 meter band. We're about 1.7 maybe. We get down to the very beginning of the band about probably 1.18 or something like that. I could actually put a marker there and look at it, tell you for sure. Let's see, marker 1.224, I guess, pretty close. The very upper of the band, where are we? We're about 1.742. Here we are on the 10 meter band. Let's see what we end up at. We get 1.842. You can see it right up here. This is marker 1 I'm using. And at the very bottom of the 10 meter band, we get about 1.5 to 1. If we come on down from 10 meter to the 17 meter, it's hard to even see that rascal. It looks like we're somewhere around here. 1.3, maybe to 1.5, something like that. And here we have the 15 meter. And it's 1.51 at the high end, about the same at the low end. Gets down as low as 1.276 to 1. We come on up here to the 17 meter band. It's so narrow it's not even funny. It's about 1.2, 1.19, 1.2, somewhere in there at that band. And then when you get into the 20 meter band, it looks like probably at the very top end, we're 1.665 to 1, and at the bottom of the band, we're probably, hard to tell here, but about 1.4, 1.5 to 1. And we dip all the way down in the middle of the 20 meter band. We get as low as about 1.052 to 1. So, I think you would agree, the antenna tunes up great on the bands. It's been this way since the day I installed it. Took no adjustments. Literally build it per the instructions. They've already got the cables cut, so they're the length they are. So tuned up like this, fantastic from the get-go. Been happy with it on this part. Does it work? Absolutely. Do you need a tuner? No, you do not need a tuner for this antenna. So with that, let's jump back over on the bench. Okay, so I think I've proven from a technical point of view the antenna works and does what they say. Now let's talk about real performance in the shack. Here's what I can say about my Hexbeam. I've never had a better antenna. When I say that, I mean for 20 through 6 meters, I've never had a better antenna. I've never had a big, giant, multi-element Yagi, so understand that. But I've tried all kinds of wire antennas and dipoles and in-fed half waves and you name it. Loops. Loop's a good antenna. Quiet, really good. But as far as the Hexbeam, I set up the Hexbeam and build it. They recommend you put like a bucket on the ground, put a pipe in it with concrete or sand, and set the center section on and start building your antenna on the ground. Hooking up your coax and just making sure it acts like it's looking good, SWR and stuff, before you put it up on the tower. I did that. My buddy had told me his experience with his, and mine exactly parallels. I'm sitting here. This antenna is probably 2 feet off. Well, yeah, probably 2 feet, 3 feet off the ground. Picture it sitting on a 55-gallon bucket in the yard. Got buildings around it. I go in and turn the radio on. I check SWR. Looks good. Go through, run the nano VNA on. Looks like what we just saw. Great. Flip over to 20 meters. I start scanning through the band, and I am hearing signals like the difference between a typical weekend and a contest weekend. That's the difference. I'm going to describe it that way. Everybody knows what that's like, okay? That's what it was like, just putting a different antenna on. It wasn't a contest weekend, but it sounded like a contest weekend with my other antennas. I'm swinging through there, and I'm hearing DX countries all over. Stuff I hadn't heard, I'm hearing it fantastic. Hear a German station right off the bat. He's running a pileup. Normally in a pileup up till this point, it's a matter of calling and calling and calling. And if I'm lucky, eventually I'm going to get a call back. I keyed up, and I know this sounds fictitious, but I keyed up, got a pileup going on. I looked up the call sign, seen where he was, went out there, spun the antenna around by hand. It's not on a rotor. Went out, spun it around roughly to the direction he was in. I was pretty close to pointing that way already. Come back in. His signal's even stronger. He calls QSL. I keyed up, made my call sign, let go, expecting, all these calls, and he comes right back to me. First call. Gives me a 5.9. I'm like, wow, That's impressive. But that could have been luck. So I start playing around and I'm hitting DX stations with this thing sitting on the ground. I couldn't believe it would work that far off the ground. It worked fantastic sitting right on the ground. Here's the kicker. When I put it up on my tower and put it up, it works even better up there. I don't know how to describe going from other antennas to a hex beam when you haven't had, big, giant, massive Yagis and stuff. It's a dramatic difference. You hear these calls and you hear them light and you hit that rotor and you spin 90 degrees around to where they are and your S meter runs up to, S9 plus 5. When they were S5, you could pull them out over the noise, but you spin that thing around and then the needle climbs up. It's dramatic, the difference. I immediately, once it was up in the air, started collecting countries like I hadn't in any other time that I was a ham. I've been a ham about working towards 40 years, 30 something years. I've never collected countries. I hit DXCC. I'd always, thought, well, DXCC, that's for people with big stations. I racked up DXCC in literally like 4 months. I picked up countries I never dreamed of getting before. So does hex beams work well? Yes. And if you find someone who's got one and put it up, they're probably going to tell you the same thing. I can go online and show you over and over again people talking about hex beams and telling you how much they love them. If you're a fan of the Solder Smoke podcast and their YouTube videos, just go find some of the previous podcasts and videos where the head guy there got a hex beam. He raves for 6 months. Every time they do a video, he's in there raving about his hex beam. They're that good, guys. They're that good. Remember, 6 bands. You're getting this on 6 bands. This is not a 1-bander or 2-bander antenna. 6 bands. So if you don't have any of those reasons why a hex beam is not good for you, if you're looking to do better and you don't have directional antennas right now, you don't have the money to put up a whole bunch of big mono-bander quad element antennas, a hex beam's the way to go. That's what I have to say. I hope that's some good information. I hope that helps you out. I hope you can make a good decision on whether to buy a hex beam or not based on that. So, hey, I hope this didn't run on too long for you, and I hope you learned something from it. I hope to see you in the next video.